So let us get started with linked list. But before we can get started, I wanted to show you a couple of things. So let us go back to our terminal and I am inside my IEX. Now in case if I want to see the info for a list, so let's create a list 1, 2 and 3. Here we get back a couple of information parameters for our list. And here we can see that we have a couple of implemented protocols. And one of the most important protocol is this one. So this stands for enumerable, that means in short as enum. And let us go to the official documentation and there I can explain all of these things. So this is the official website for Elixir, it's elixirlang.org. Let us go to docs and here we want to see the documentation of the current stable version. So this takes us to a new website and as you can see this website is called as hexdocs.pm. So hex is like the package registry for Elixir. So in case if you go to this website hex.pm and here we can search for different packages. Suppose you want to search for Phoenix, then you can search for Phoenix right over here. And this is going to list all of the packages. So this is the official package for Phoenix. And if we click on the online documentation, it will take you to the docs page. And this is the official documentation for Phoenix. Now let us go back to the documentation for Elixir. And as you can see, we have two tabs right over here. So this tab is for the pages and this tab is for the modules. Now this module of kernel is automatically imported for us. We don't have to import this kernel. The next module which I wanted to show you is for our list. So let us scroll a little bit down and inside this section of collections and enums, we have our list right over here. And here we can see that we have nice documentation in place. And also we have a couple of functions that are implemented on the type of list. So here we can see we have different functions. And if you want to see documentation for any of the functions, you have to just click on this one. And this opens up the documentation for the requested function. Now in the terminal, we saw that list also implements the protocol for our enum. So let us check out the documentation for enum. Let me collapse my list and let us go to the documentation for enum. So enum basically helps you to iterate over your list or any of the collections. And most of the functions for your iterables are inside enum. And some of them could be in list or maps or hash map, but enum would be your most frequently used module. And as you can see in the documentation, the first example itself uses a list. The second example also takes a list and simply gives back the sum of the list. So what we can do is let us try and replicate this functionality by using our list and recursion. So now let us go back to our code editor. Now here let us create a new folder. So inside my directory of lib, let us create a folder by the name of list. And inside this folder, let us create a new file by the name of list.ex. And let us first define the module. So this has to be .tutorials. And this naming convention doesn't make any sense. So right now, let me just take out this list and let us name the module as tutorials.list. So let me define a function called as sum, and this is going to take a list of our numbers. Now first let us think of a base case. Suppose we get an empty list, so at that time we can simply return back a 0. So let me define a base case on the top. So I can say define my sum and let us pattern match on an empty list. So we can just write empty list right over here. So in case we get an empty list, we simply want to return back a 0. So now let us see how we can write the recursive case. Now what we can do is this parameter of numbers, this is actually a list. So we can pattern match right over here. So what I can do is let me take out this parameter and let us pattern match inside the function definition. Let us collect the head inside a variable called as h and let us collect the tail inside a variable called as t. Now let us see what we want to do for each iteration. We simply want to add the head along with the sum, and each time we simply want to pass the tail. And that's it, we have a recursive function for adding all of the elements inside the list. Now as you can see that this is not a tail recursive version. So what we can do is let us try and rename this file. So instead of calling this as sum, let us rename this function from sum to sum simple. And here what we can do is, since this is just one single line of return, let me take it to a single line. Let me put the quotes, and we don't need the end block. And let us open up our terminal and see if this is working or not. So let me go inside my IEX and let me clear up my terminal. And here we can say that from the module of tutorials, I want to go to the module of list. Then I want to invoke the function of sum simple, and let us pass the list of 1, 2 and 3. And as expected, we get back the answer as 6. Now what we can do is, we can also write this function by using tail recursion. So let us see how we can create the tail recursive function. So we can call that function as sum and tail recursive, and let us think of different parameters that we can pass for our tail recursive version. This function will accept two parameters. The first is obviously our list of numbers, and we also need an accumulator. And what we can do is, let us define the function definition right over here. So we can say that the default value for our accumulator has to be 0. And now since we have just created the function definition or the function header, we don't need to create a body for this one. Next, let us write the actual implementation. So let me just copy and paste. So here we don't need the default argument. And first let us think of the base case. So in case the numbers is just an empty list, so at that time we simply want to return back our accumulator. The next is our recursive case. So let me again copy and paste. Now this time again we can pattern match on the head and on the tail. So we can say that we want to collect the head and we also want to collect the tail. And for each iteration we simply want to call the same function back. But now for each iteration we simply want to pass the tail. We don't need to pass the head for each iteration, and our accumulator becomes our accumulator plus of our head. And that's it, we have a tail recursive function as well. Now let us do one simple thing. Let me go at the top, and here let me create a function which is called as sum, and this accepts our numbers. And here let us simply call the tail recursive version. So we can say that I want to call my tail recursive version, and let me pass numbers to it. So now we have a much smaller name, and this makes our life much more easy. So let us go back to our terminal. Let us recompile tutorials.list. Let me clear up the screen, and let us invoke the same function, but this time the name of the function is just sum. And as expected, we get back the answer as 6. And this time for calculating the sum, we are using the tail recursive version. Now going forward, I'm not going to draw the recursive trees, but if you're not feeling confident or if you're feeling confused, then I highly motivate you to draw the recursive trees. Now before ending this video, I wanted to show you a couple of things. The first thing is, let us see how we can document all of our code. The first thing is, we can use something which is called as module attributes. So on the top we can say that we want to create documentation for the entire module. So let's document what we are going to do for this module of list. We are going to implement a couple of functions that can be used on the list. So I can create a heading for our function summary, and the first one that we have implemented is for our sum. So this is how you write the module level documentation. Next, let me show you how we can write the documentation for our function. So for this, we can use the module attribute of just doc, and inside the quotation marks, let us write the documentation saying that this function returns the sum of the numbers inside a list. So now if you hover over the definition of sum, we can see that the code editor is showing us the documentation. And the last thing which I wanted to show you in this video is how we can define the type specifications or the type hints. So here we can use another module attribute by the name of spec. So this stands for the function specifications. So here we want to define the specifications for our function of sums, and here we can define the type of this parameter. So in our case, sums is actually a list, and the list contains different numbers. So this is how we can define the type of numbers. The next comes the return type. So here we can put double quotes, and we can say that the return type is also going to be a number. So what we have done is we have also added the documentation and we have also added the specifications. So in the future, whenever you are using tools like Dialyzer, it will help you to catch bugs inside your code. Next, let us write the specifications for our other functions as well. So let me copy this one and let me paste it right over here. This function is going to be our sum of simple. Next, let us also write the specification for our tail recursive function. So here I can say that this function name is actually my sum of tail recursive. Now this function accepts two parameters. The first parameter is a list of numbers. The second one is simply an integer. So we can say that the second parameter is an integer and the return type is number. And if you want to read more about the type specifications, then we can go to the official documentation and we can go to the tab of pages, and here we can see that we have the documentation for our type specifications. Right now, don't worry too much about type specifications. I will show you how we can write the specifications from here on. Well, that brings us to the end of this video and I will catch you in the next one.